Okay, so here we are on quiz number 3, which is Unit 2, homeworks number 1 through 3. Okay, so does 4 factorial divide evenly into 30? Well, 4 factorial is 4 times 3 times 2 times 1, which is what, 24? Does 24 divide evenly into 30? No, it goes in once, but it has a remainder of 6, so it doesn't go in evenly, right? We're talking about divides evenly, so false. That one does not divide in evenly. Part A is false. Let's take a look at part B. Does 80 go into 25 factorial evenly? Now, let's break down the 80 and see what's in there. This is 8 times 10. 2 times 4, 2 times 5, and the 4 breaks down to 2. So really we've got 2 to the 4th times 5, right? 1, 2, 3, 4 2's and a 5. Does that go evenly into 25 factorial? Well, yes, I think it does, because if you break down the 20, now we can't multiply the 25 factorial all the way out, but if we break it down to the little pieces that are in there, we're looking for 4 2's and a 5, right? Because this number, which is an 80, goes into 25 factorial if all the pieces are in there. If 4 2's and a 5 are in there. Well, here's the 5's right away. We got plenty of 5's. Do we have 4 2's, though? Yeah, we do. Because 24 is 4 times 6. That's 2 2's. 6 is 2 times 3. So there's 3 2's already. 22 is 2 times 11. There's 4 2's. Yep, so we got 4 2's and 2 5's easy. That one is true. Let's go on to part C. Okay, so part C, does 15 divide evenly into 10 factorial? Well, what's in a 15? 3 times 5. Do we have that in 10 factorial? Well, 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Is there a 3? Well, yeah, there's a 3 right there, plus the 9 has a couple extra 3's. Is there a 5? Yeah, the 10 is 2 times 5. We got plenty of, we have at least 1 3 and 1 5. That's for sure true. All right, how about part D? That was part C. Part D says, does 48 divide into 6, evenly into 6 factorial? Well, if you do 6 factorial, 6, 5, 4, 3, 2, 1, and you break down the 48, what's in a 48? 6 times 8, that's 2 times 3, 8 is 2 times 4, break that down, 2 times 2. So we got 1, 2, 3, 4, 4 2's and a 3. So 4 2's and a 3, does that go into 6, 5, 4, 3, 2, 1? Well, what's in there? What's in the 6? 2 times 3. What's in the 4? 2 times, there's 2 2's, 3 2's, 4 2's, and a 3. Another 3 there. Yep, we have 4 2's and a 3. We got it. True. Let's go to part E. So part E, does 2 to the 60th divide into 100 factorial? Well, what's in 2 to the 60th? Well, 62's. I mean, there's no way to break that down further. It's just 62's. What's in 100 factorial? Well, that means 100 times 99 times 98 times 97 times 96 times 95 times 94 times 93, all the way down to 1. So are there 62's in there? Yeah, for sure, because just think about the 100, for example. Well, first off, every other number has a 2, right? 100, 98, 96, 94. Half the numbers have a 2, right? 98 is 2 times 49. 96 is 2 times 48. 94 is 2 times 2 times 47. So yeah, they all, so every other number has a 2. So there's 52's already. Right off the bat, we've got 52's. Half the 100 numbers. Half the 100 numbers have 2's in them. So there's 52's. Now, how about the 100. That's 10 times. Are there 10 extra 2's? Well, 100 has 2 2's, so there's 1 extra. This one right here, this 96, if I keep breaking him down, 6 times 8, 2 times 3, 2 times 4, 2 times 2, look at that. There's a bunch of extra 2's in addition to the first 2. There's 1, 2, 3, 4 extra 2's. Had an extra 2 there, that's 5 extra 2's. Yeah, we'll easily come up with 10 more. 10 more 2's. So yeah, we'll easily have the original 52's, because every other number has a 2, and 10 more 2's because some of these numbers have a bunch more 2's, so that one is certainly true. Okay, and then finally here, part F. Bring that up. Does 30 go into 30 factorial plus 1? Well, the trick on this one is to realize that 30 does go into 30 factorial. That part is a yes. Because, right, 30 factorial means 30 times 29 times 28, etc. So certainly 30 can go in there because 30 goes into that 30. So yeah, 30 goes in. But what about when you add 1? What's the story with that? Well, that's 30 factorial plus 1 is such a gigantically crazy big number. We can't easily figure that out. But instead, let's just think about the principle. What happens if you go into a number? Let's take an easy situation. Like 6 goes into 6, right? One time perfectly. So what happens if we add 1? 6 plus 1. That'd be 7. Does 6 go into 7? Goes in one time, but then there's a remainder. It does not go evenly, does it? So if you go into a number evenly and then you add 1, you no longer go in evenly. So 30 goes into 30 factorial evenly, but when we add 1, it becomes a no, false. Does not go in evenly. So, there we go on that one. So here's number 2, and we want to find the largest end so that 2 to the n goes into 2 to the n divides evenly into 14 factorial. So what's in a 14 factorial? 14 times 13 times 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So what we're looking for is how many 2's are in that 14 factorial. Let's break down all these numbers now and find all the 2's so we know how many 2's go into 14 factorial evenly. This is 2 times 7, so there's a 2. Now 13 doesn't have any 2's in it, right? 2 does not go into 13, but 12 does. 4 times 3, 2 more 2's. 11 is odd, 2 doesn't go into it, but 10, 2 times 5, there's another 2. 8, 2 times 4, 2, 2, so there's 1, 2, 3 more 2's. 6, 2 times 3, 4, 2 times 2, and then just the plain 2 itself. How many 2's is that? 1, 2, 3, 4. Here, let me count with a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 2's. So the 11th power is the largest power. 11 power here is the largest power I could put on that 2. That's the most number of 2's that will go into 14 factorial because that's how many 2's it can hold. All right, let's try part B. Now, part B is kind of the same thing, but even a little more tricky. We're saying, what power on a 6 will go into 20 factorial? We better get a fresh screen here. Okay, so what power on a 6 can go into 20 factorial? So we're going to have to break down that 20 factorial. So 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, I'll bring it down here, 8, 7, 6, 5, 4, 3, 2, 1. Now, what's in a 6? A 6 is 2 times 3, right? To the nth power. So 2 times 3 to the nth power. That's what we're looking at. 2 times 3 to the nth power. So 6 is made out of 2 times 3. We want to know how many 2's and how many 3's are in all this stuff, the 20 factorial. Well, if you think about it, there's going to be a lot more 2's than there are 3's, right? Because every other number, like 20 has a 2, 18 has a 2, 16 has a lot of 2's. It'll be no problem to find the 2's. What we're going to be limited by is 3's. There's going to be way less 3's. So let's just look for how many 3's there are. Let's start right here. Here's a 3. And then 6, 2 times 3, right? Any number that 3 goes into is going to have a 3. What's the next number? 9, right? 9 is got 2 3's. How about 12? 3 times 4. I don't care about breaking it down anymore. I'm just looking for 3's. The next number would be 15. I'm just doing all the numbers that 3 goes into. There's a 3. How about 18? 2 times 9, 3 times 3. So there we go. How many total 3's? 1, oh, don't forget this one, 2, 3, 4, 5, 6, 7, 8 3's. So there's 8 3's. Now, how many 2's are there? Well, there's lots of 2's. Again, like I was saying, 20 is 4 times 5. There's 2 2's already. There's another 2. That's 3. 16, if you break that down, it's 4 times 4. 2, 2, 2, 2. There's 4 more 2's. And then 14 has another 2. 12 has 2 more. We've already got more than 8. So I'll say more than 8 2's. Way more than 8 2's. So basically, anytime a 2 and a 3 get together, they make 6. 2 and 3 get together, they make 6. So how many 2's and 3's are going to get together? Well, only 8 of them, right? Because there's less 3's. So they're limited by what there's less of. There's less 3's, so there's 8 3's. So the answer here is going to be 8. 6 to the 8th power is the biggest power because 2's and 3's, 8 of them can fit into 20 factorial. We have room for 8 3's, and we have more than room for 8 2's, so we can fit 8 6's that way. Okay, so smallest in, so that 36 divides evenly into n factorial. Well, let's break down the 36. What's in a 36? 6 times 6. 2 times 3, 2 times 3, so 2 2's and 2 3's. So then I'm just going to start trying numbers. What about 2 factorial? That's just 2 times 1. 2 2's and 2 3's won't fit into just 2 times 1. Let's try 3 factorial. That's 3 times 2 times 1. That can't hold 2 2's and 2 3's. Let's try 4 factorial. That's 4 times 3 times 2 times 1. That's got 2 2's here and a 2 there. Plenty of 2's. It's got at least 2 2's, but it's only got 1 3. So that's not going to work. Let's keep going. How about 5 factorial? That's 5, 4, 3, 2, 1. Does that have 2 2's and 2 3's? Again, here's all the 2's we need, but only 1 3. So we got to keep going. How about 6 factorial? That's 6 times 5 times 4 times 3 times 2 times 1. Does that have 2 2's and 2 3's? It does. See, there's the 2 2's. There's an extra 2. Here's one of the 3's, and 6 is 2 times 3. There's the other 3. So that's the smallest number. That's the first number that works, right? Because if we went higher, if we went to like 7 factorial, that would have everything that 6 factorial does, plus it would have a 7 in the front. So that would work also. That's why 6 factorial is the smallest one that works. Bigger numbers than that would also work because they have everything the 6 factorial has and even more in the front. So the smallest number that'll work is 6. 36 will divide evenly into that because it's got 2 2's and 2 3's in it. Let's try part B. Okay, so part B, does 80 go into, or find the smallest n, so 80 goes into n factorial. Same ball game here. Let's break down the 80. 8 times 10, 2 times 4, 2 times 5, 2 times 2. So 1, 2, 3, 4 2's and a 5. 4 2's and a 5. That's what we're looking at. So let's start with 2 factorial. That would just be 2 times 1. There's not 4 2's and a 5 there. Let's go up the line to 3 factorial. 3 times 2 times 1. There's not 4 2's and a 5 there. Let's try 4 factorial. 4 times 3 times 2 times 1. Are there 4 2's and a 5? There's not even a 5 there. Let's go to 5 factorial. 5, 4, 3, 2, 1. Are there 4 2's and a 5? There's the 5. Are there 4 2's? 2 2's there and 1 2 there. Only 3 2's. So not 4 2's. Let's go to 6 factorial. 6, 5, 4, 3, 2, 1. Does that have 4 2's and a 5? Here's 2 2's. Here's another 2. And the 6 has another 2. 1, 2, 3, 4 2's. And there's the 5. So that's the smallest number that'll work. N equals 6. Okay, so on number 4, wanting to add fractions. Remember, to add fractions, you need common denominator, multiply top and bottom by the common denominator to get minus 7 21st plus 18 21st. Just use your calculator. What is that? 11 21st. There we go. Let's try the next one. Going to need to use our calculator again, so multiply top and bottom of this one by 4. Get 19 24ths minus 20 24ths minus 1 24th. Just common denominator there. Let's try the next one. This one, what's going to be, okay, 2 and 4, it's going to be 2, but I got to multiply by the other letter also. 2x here and here, top and bottom by y. So then we'll get 7y over 4xy plus minus, what's this going to be here? 10x over 4xy. See how that made both denominators? 4xy made both denominators the same. So how do you put that together? That's just going to be, this is part C, that's just going to be 7y minus 10x all over 4xy. It's just one big fraction like that. Is that good? Let's go to the next page and we'll try D, E, and F. Okay, so this time, so basically you have to multiply, I'm on D, multiply top and bottom by whatever you need to make all the denominators the same, right? Whenever we add or subtract fractions, we have to have common denominator. So this one seems to have everything. What is this denominator missing that he needs to become the same as the other guy? He needs to have an x on the top and the bottom, doesn't he? And then he'll have 3x squared y squared. And this one, he needs to have a 3 and a y. And then, see, his denominator now will be 3x squared y squared. This one will be 3x squared y squared. And this one already is 3x squared y squared. So then that'll be negative 5 over 3x squared y squared plus this one will be 2x over 3x squared y squared. And this one will be 21y over 3x squared y squared. So then just put them all into one fraction. Minus 5 plus 2x plus 21y all over 3x squared y squared. So once they all have the same denominator, so you multiply top and bottom to make all the denominators become the same, and then you just make it into one big fraction at that point. Let's go on to E. So on part E, we have 9 tenths minus. Now, what do we do with mixed numbers? We have to change it to an improper fraction. You multiply the bottom, add the top. Remember, 3 times 8 is 24. Add 7, what's that? 31/8. So we have to change to improper fraction. Multiply the bottom. 3 times 8, 24. Add the top. So now we got to multiply to make the two denominators the same. So I'm going to multiply top and bottom by 4 top and bottom by 5. I'm going to make both of them 40. Now, you could have made them both 80. That's okay. You can make both denominators 80. So 36 over 40 minus this would be 155 over 40. So now we can subtract them. Let me grab my calculator. I'm not sure what that is on the 36 minus 155. I'm getting minus 119 over 40. So there we go. And then finally, I think we can squeeze in part F down here. So that was part E. Down here, part F. So you're going to need to multiply the bottom, add the top again. That'd be minus 12. Oh, that'd be minus 12 of 13 fourths. Right? 3 times 4 is 12. Add 1, 13. And then 1 times 12, add 1. Plus, was it 12, 13, 12. So you always have to change mixed numbers to become improper fractions. And now, common denominator is needed. So multiply top and bottom by 3. Minus 39 twelfths plus 13 twelfths is minus 26 twelfths. And then you can reduce it. We have to reduce. Whenever we can divide top and bottom, we need to do it. So that'd be minus 13 6. And divide top and bottom by 2 there. Okay, so on number 15, we're supposed to arrange in decreasing order, which means we want the biggest, the medium, and then the smallest. That's what decreasing order means, going down, right? From the biggest down to the smallest. So as you look at these three, how do you know which one is the biggest and which one is the medium and which one's the smallest? Well, I notice that all the numerators are the same. All the tops are the same, right? So remember that a fraction is really dividing, isn't it? So imagine if I have like 9, let's say, candy bars. And I divide it among, let's say, 2 people. Well, they each get 4.5 candy bars, don't they? Whereas, what if I take those same 9 candy bars and I divide it among 10 people, or let's say 9 people. Divide it among 9 people. They each get 1 candy bar. They get less. And now what if I take the 9 candy bars and divide it among 18 people? They each only get half a candy bar, don't they? So the bigger the number of people that you divide it, or the bigger the denominator, the less candy bar you get. Right? Right? 9 candy bars divided among 12 people. 9 candy bars divided among 17 people, they get a little less. 9 candy bars divided among 19 people, you get a little less candy bar every time. So the smallest is 9/19. The medium is 9/17, and the biggest is 9/12. When the denominator gets bigger, the fraction gets smaller, doesn't it? All right, let's go into part B. So in part B, we're looking at these 3 fractions. Trying to go decreasing order. I think one nice way to start this problem is just to compare the front. Now remember, you can't just do this on your calculator. I mean, of course you can in the homework, but on the test, you'll have to do these without a calculator. I'll have a few questions in the beginning that say do this without a calculator, so you'll have to be able to do it with no calculator. So make sure you can do this without a calculator, right? Because otherwise we could just divide them on our calculator, get the decimals, and decimals are really easy to tell which one's bigger or smaller. But the purpose is to learn to think about fractions a little bit better. So we want to do this without using a calculator and decimals. Okay, so one thing we could do is we could take that minus 23/25. I'll put them here like this. Whoops. And if we could make these two have the same denominator. Let's do that. So, right, because if you make the denominator the same, you can compare. This is minus, 2 times 5 is 10 25ths, and this is minus 23 25ths. So that's good. That's helpful. Hey, let's get rid of the negative signs for a minute, because that's just making it hard. Let's just make them all positive. Okay, so if I just make these guys all positive, and I'll change to negative in a minute. If I make these all positive, just comparing these two, which one is a bigger fraction? 23 25ths or 10 25ths? Well, clearly, this one is the biggest, right? 23 25ths is bigger than 10 25ths. It's easy to tell once they have the same denominator. Now, okay, so that's good. I know this was the biggest. Now, how do these two compare? Which one's bigger among those two? Well, can you tell that 10 25ths is less than a half? Right? Because if I said, hey, 10 out of 25 people got an A on the exam, that's just under half the class, right? 12 or 13 would be half. That's just under half. What if I said 11 out of 16 got an A? That's more than half the class, right? So this fraction is bigger than that fraction. This is more than a half, that's less than half. So this one's the medium, and this one's the small. But that's if they're positive. Negative reverses all that, doesn't it? Do you know what I mean? Let me show you on the number line. If you have like here's 0, you know, here's a, let me do like, kind of messing this up here. Let me try this. What if that's 0 right there, and this is 1? Here's a half. A fourth is less than a half, right? But what happens on the negative side? If this is negative 1, this is negative a half, this is negative. See how a half is bigger than a fourth, but on the reverse side, the negative side, the minus 1/4 is bigger, right? Bigger is further to the right. So the negative reverses, see they come over like that, like a mirror image. And so whoever's bigger in the positive, he's the bigger on the positive. The other guy, the minus 1/2 becomes the smaller now. So that means if this one's the biggest, he actually becomes this one here. I don't run out of room, so let me rewrite this. So 23 25ths, 11 16ths, and 10 25ths, which came from 2/5. So if they were all positive, he would be the big, he would be the medium, he would be the small, like we showed. But when you put on the negative sign, then it reverses. The medium's still the medium, but this guy becomes the big, and this guy becomes the small. So there we go. So the biggest one should be the negative 10 25ths. So, biggest one, which is the negative 2/5. That's the biggest. So that guy should be in the front. The medium should be 11 16ths, that one. And the smallest should be the negative 23 25ths. There's our option, like that. Okay, so here we are in number 6. They're asking us to add up these fractions and give an estimate, approximation to what they add up to be. What do those fractions add up to be? Now, again, of course, we could just do it on our calculator and get an answer, but this will be on the non-calculator part of exam 2. We have to be able to add these up without a calculator. So how can we do that? Well, what I suggest, let me write them over here. 7/15ths, 8/17ths, 19/39ths, and 22/45ths is just estimate, estimate about what it is. So 7/15ths, isn't that about a half, right? If I said 7 out of 15 people got an A on the exam, that's about half the class. How about 8 out of 17? That's also just about a half. 19 out of 39, that's like 20 out of 40. It's about a half again. And 22 out of 45, they're all about a half. Approximately, right? So if you add up a half and a half, you get a whole, and a half, you get a whole, and one is 2. The answer is 2. These are very close to 2. See how we can figure that out without figuring out the exact answer? We know it's super close to 2. Let's try part B. Part B is saying, okay, take 202 out of 301, add 2 out of 1,000, and 3 out of 2,000. Well, think about it. 200 out of 300 people. What is that? That's about 2/3, isn't it? 200 out of 300 is really, really close to 2/3. What is 2 out of 1,000? If I say 2 out of 1,000 people got an A on that exam, that's virtually nobody. If you do that on your calculator, again, I know we're not supposed to use a calculator, but I want to prove it to you. That's 0.002, right? 2 out of 1,000 is basically 0. I mean, it's super close to 0. Same thing here, 3 out of 2,000, that's basically 0. It's approximately 0. It's really close to 0. It's a super small number. If only 3 out of 2,000 people get an A on a test, that's virtually nobody, isn't it? So, add up 2/3, nothing, and nothing. It's approximately 2/3. There we go. Okay, so now number 7. So if D divides A squared, then D divides A. Remember, these are the ones you're supposed to put numbers into. So let's try it out. And we're looking for false. So if D divides evenly into A squared, then D divides into A. Okay, let's try a number. What if I try putting in like 2? 2 goes into 3 squared. Then 2 goes into 3. So I just picked D to be 2, A to be 3, D to be 2, A to be 3. Does that work? Does 2 go into 9 evenly? No. Stop right there. Then this isn't even valid. Remember, you have to make the if true. You can't, like if somebody said, if I look out the window and see a dog, then it's a poodle. Now, that's not true. If you look out the window and see a dog, then it's a poodle. That's not true. Not all dogs are poodles. But if you're going to prove them wrong, you're going to have to look out the window, see a dog that's not a poodle, right? You'd have to see a German Shepherd or something. Go, look out the window. There's a dog that's a German Shepherd. See, not all dogs are poodles. That would prove them wrong. What if you looked out the window and saw a cat and said, hey, that's not a poodle? That would not prove them wrong, even though they are wrong. That would not prove them wrong. Because they would say, I didn't say cats are poodles. I said dogs are poodles. You got to show me a dog that's not a poodle to prove me wrong. Right? So you get the idea. We always have to meet their if. Whenever somebody makes an if-then statement logically, we have to meet their if and show them that their then doesn't hold to prove them wrong. And that's what we're always trying to do on these, is prove them wrong. And if we can't prove them wrong, then we assume it must be right. So this was a bad first example. That isn't going to work. So I can't use 3. Let's try if 2 goes into 4 squared. Is that true now? 2 goes evenly into 16? Yeah. 2 goes into 16 evenly, goes in 8 times, no remainder. Then 2 will go into 4. Does it? Does 2 go into 4? Yes, that's true. So it must be true. No, hold on. Just because something's true one time doesn't mean it's always true, right? If I look out the window and I see a poodle, that doesn't prove all dogs are poodles. It doesn't, right? If I look out the window and see a dog and it is a poodle, that doesn't mean, if I say, if I look out the window and I see a dog, then it's a poodle. I can't prove that by going, come here, look out the window. And you look out the window and see a dog and it is a poodle. And you go, see, there's a poodle. That one's a poodle. So all dogs are poodles. No. It's only true if it's always true, right? If you make the statement, if it's a dog, then it's a poodle. That's only true if all dogs are poodles. So just because it's true one time doesn't mean it's always true. So what you have to do on these, that's why these are hard, is you have to try several times until you get false. And if you can't get false after a lot of times, then you start to think maybe it is always true. So let's try a different number. What's another way we could do it? How about if we turn it around? If well, how about we just do like 6? If 6 goes into, well, no, let's turn it around. That's a tricky one. If 4 goes into 2 squared, then 4 will go into 2. Now, does 4 go into 2 squared? Yeah, 2 squared is 4. 4 goes into 4. Yes, that's true. Then 4 will go evenly into 2. No, 4 does not go evenly into 2. Ah, there it is. There's a counterexample. If you let the B be 4 and the A be 2, it is false. So this is a statement that's not always true, but it's usually true. So that's a tricky one to break, isn't it? See, these are hard. So the first one worked, but the second one did not work, which shows it's not always true. Sometimes it's false. So overall, the statement is not a statement that's always true. It's a statement that is sometimes false. Let's try B. So on B, come up here, if D does not divide into A, then D does not divide into A squared. Now, is that true? Okay, we got to meet the if. So you got to pick a number like 2 that does not divide into something like 3. That's true, right? 2 does not divide evenly into 3. I met their if. They said, give me a D that does not divide into the A. Then, so that's true. Then, D, that 2, will also not divide into 3 squared. 2 does not go into 9 evenly. Is that true? Yeah, that's true. That seems true there. But again, no, I'm not going to say true. On a test, if you get true, go ahead and bubble true and go on with the rest of the test. And if you have time at the end, come back and try to do further testing on the ones that are true to see if you can find a way they're false. But I'm going to do it right now. Let's try another pair of numbers. Can anybody think of a way to break this? Well, how about let's do the 4 and 2 again thing. 4 does not go into 6. Let's do 4 and 6. 4 does not go evenly into 6. Then 4 will not, put the not there. 4 will not go into 6 squared. 4 does not go into 36. Oh, yes, it does, actually. 4 does go into 36. Not true. This one's actually false also. If 4 does not go into 6, then it'll not go into 36. No, it does go into 36 9 times perfectly. So this is not true. So we found a case. Again, sometimes these things are true, but this one is not always true, so it's a no. That's what's hard. Both these have been false, but they look true sometimes. Let's try part C. Part C. So if D does not go into, does not divide into A squared, then D will not divide into A. Is that true? Well, we got to meet the if. So pick something like, I don't know, 2 does not go into 3 squared, right? 2 does not go into 9 evenly. That's true. So I met their if. Got to meet the if. Then 2 will not go into, oops, number was 3, wasn't it? A was 3. A squared was 3 squared, so A is 3. Then 2 will not go into 3. Yeah, that's true. 2 does not go evenly into 3. This one is actually true. You could try it again and again and again to break it, and you'll find out that it always holds true. If D does not go into A squared, then it cannot go into A. There's no way it can go into A if it doesn't go into A squared. All right, let's move on. Let's try part D. The LCM of A and B divides evenly into A times B. Is that true? Well, let's pick a couple numbers. Let's find the LCM of 2 and 3 and see if it divides into 2 times 3. What is the LCM of 2 and 3? So remember how to find LCM? It's like a least common denominator. What if you had a half and a third? What's the LCD? It'd be 6, wouldn't it? The common denominator would be 6. So that's what LCM is, the same as LCD. Same thing. I know we learned some formal ways of figuring out common denominators earlier, but you can also just kind of look at it. So 6, and what is 2 times 3? It's also 6. Yeah, that's true. 6 does go evenly into 6. That's true, yes. Is this always going to be true? Yeah, it is. You can try for a long time. It'll always be true. The LCM of A and B always goes in to A times B. Let's try part E. Bring it up here. Part E. If the GCD of A and B is A, then A divides evenly into B. That's a confusing situation. Let's try that one. So what? Okay, so the GCD of A and B. So the GCD. So if the GCD, let's pick an A and a B. How about 2 and 3? And what is the GCD? The GCD. Well, that's the GCD is the greatest number that divides evenly into both numbers. Remember what a GCD is? The greatest number that divides evenly into both numbers. So what's the biggest number that goes evenly into 2 and 3? It's only 1. So if that's the case, then, hold on. They said the GCD of 2 and 3 is supposed to be the first number. Did it come out to be the first number? No. So my example does not meet the if. So don't even go any further. It's a bad example. Try again. It's like I looked out the window and saw a cat and said, hey, that's not a poodle. The person would say, I didn't say cats were poodles. I said dogs were poodles. So they said if the GCD is A, then something else will happen. So we've got to make the if true first. So if the GCD, so we got to pick 2 numbers. How can we do it? What are 2 numbers where the GCD will just be the first number? How about 2 and 6? What divides evenly into 2 and 6? 2 does, huh? So see how that comes out to be the first number? And that's what they said. The GCD of 2 numbers has got to be the first number. If that's the case, then that first number, right, A, the first number, will divide evenly into the second number. Does it? Does 2 go evenly into 6? Yes, it does. Yeah, this is true. You could try it for a long time. Anytime you meet the if, the then will also be true. That's a valid, true, if-then statement. Finally, here we go, part F. Let's bring up part F here. If A and B are even, then the GCD of A and B is 2. Okay, let's test it out. So you got to pick even numbers like 2 and 4. So if 2 and 4 are even, they are, 2 and 4 are even. So we met the if, didn't we? Got to meet the if, we did. Then the GCD, the greatest common divisor, of 2 and 4 will be 2. Is it? What's the greatest common? Remember, that's the greatest number that divides evenly into both. What's the biggest number that goes into 2 and 4? What's 2? Yes, that turned out to be true. So maybe this is always true. Should we go with true? No, remember we got to test it further. This is not always true. Let me prove it to you. How about if we pick 4 and 6? They're even. Oh wait, no, sorry, 4 and 6. 4 and 6 is not a good example. How about 4 and 8? 4 and 8 are even, right? It says then the GCD of 4 and 8 will be 2. Is it? What's the greatest number that goes into 4 and 8? It's 4, not 2. So no, this is false. It's not always true, even though it was true sometimes. It's not always true, so it's false. That's what makes these so hard, is you got to find out if they're always true or not. Okay, here we are on number 8. If A divides B and A does not divide C, then A does not divide B times C. That's tricky. Let's try it out. So, if A divides evenly into B, and A does not divide evenly into C, then A does not divide evenly into B times C. Okay, let me try some. Got to meet the if, right? Got to meet the if. So, if, how about 2 divides into 4? Right? I had to make the if true. 2 does go evenly into 4. I could not pick 2 and 3, right? Because that's not true, and you got to make the if true if you're even going to address the statement. They said if something is true, then something else. You got to meet the if, and 2 does not go into, so I got to pick some other number it does not go into. How about 3? I could pick 3 there. 2 does not go into 3. So 2 does go into 4 and does not go into 3, which was their if statement. I just met their whole if, right? It does go into 4, it does not go into 3. Then what they're saying is that first number, that 2, will not go into those two numbers multiplied. 4 times 3. 2 will not go into 12. Oh, no, it does go into 12. That's false. That's no. So that's nice. We're just done. If you've proved something false, you're just done, right? If it's true, then you got to test it again and again to make sure it's always true. But if you get a false, you're just done. Right there, we are done. That's a false statement. All right. Let's go on then to part B. So that was part A. And now part B. If D divides into A minus B, here, let me move this down a little bit. If D divides into A minus B, and D divides into B, then D divides into A. Huh. Is that kind of a weird one? Let's see. Let's try it out. So D, like, I don't know, 2 goes into 5 minus 3, right? 2 goes into 2, doesn't it? And, okay, D I chose is 2, and B is 3. Uh-oh, that doesn't work, does it? Right, 2 doesn't go into 3, and it says and, we got to do both. So I got to pick that second number so it goes in. So how about 6 minus 4? Because that's 2 goes into 2, and then if that second number is 4, 2 also goes into 4. Right? Is that making sense? So I picked, right, D to be 2, A and B to be 6 and 4. And then 2 does go into B now, 4. So that's, both those are true. Then D, it's D, 2, will go into A, which is 6. Yeah, that's true. That's yes. Yeah, this one's always going to be true. You could, I know I just got it true once. You could work this one again and again and again and again, and you would find that this one is always true. This one is true. Part C. If AB divides evenly into C, then A divides evenly into C, and B divides evenly into C. Is that a true statement? Let's try it out. So we got to meet the if A times B goes into C. Well, how about 2 times 3, that'd be 6, goes into like 12, right? That's 6 goes into 12, that's true. Then the first number, which was 2, will go into 12. Yeah, 2 does go into 12. And the second number, 3, will go into 12. Yeah, that's true. Yeah, this is always going to be true. You could, again, I know I'm just concluding it quickly, but you could try it again and again. It'll always be true. Let's go on to D. It says, if A divides into C and B divides into C, then AB will divide into C. Okay, let's try some numbers. If 2 goes into 4, right, let A be 2, C be 4, and B, something new, oh, we got to pick a new number. So maybe I better make this like, I don't know, 6, and B can be 3. Right? So if A goes into C, 2 goes into 3, and B goes into C, B could be 3. Those are both true. Remember, you got to make the if true. Those are both true. Then A times B, which is 2 times 3, will go into 6. Well, yeah, that's 6 into 6. Yes, that's true. But is this thing always true? It turns out no. Let me show you a case that'll break it. So we're saying if A and B both go into a number, then them multiplied goes into that number. Well, no, that's not always true. How can I prove it? If 4 goes in, if 4 goes into 12, and 6 goes into 12, right? This is A, this is C, B, and C. 4 goes into 12 evenly, 6 goes into 12 evenly. Then 4 times 6 will go into 12 evenly. No, that's 24. That doesn't go into 12 at all. It's bigger than 12. That's not true. See how that's a counter example? That proves that this thing is not always true. This is a false statement. It's true sometimes. It was true here, but it's not true there. Right? Because 4 times 6, 24, doesn't go into 12. It's too big to go into 12. So there's the case where it's not true. Let's try E. So E here. If A divides into B times C, then A divides into B, or A divides into C. Is that true? If A divides into B times C, then it divides into B or C. Well, let's try out some numbers. If 2 goes into 3 times 4, that's 12. Yeah, 2 goes into 12. Right? I met the if. Then 2 will go into the first number, or 2 will go into the second number. Now, this isn't true. 2 doesn't go into 3, but it's okay because they said or. So this part is a yes. Remember, when somebody says or, you don't have to do both, right? If I said you can apply for this new scholarship if you went to the moon or grew up in the Central Valley. If you grew up in Central Valley, even though you haven't been to the moon, you can apply, right? Or means one or the other. So they said or. It's either going to go into A or it's going to go into, I'm sorry, A is either going to go into B or it's going to go into C. They're not saying it has to go into both. And that turned out to be the case here. Yes. So it's true. Well, careful. This isn't always. This time it's true, but let me show you how it's not always true. What if I reverse it? Put a 4 out here and go, I don't know, 2 times 6. Right. See, 4 goes into 12. That's true. Then 4 will go into the first number or it'll go into the second number. Both of these are no. 4 does not go into 2 and 4 does not go evenly into 6. Even though 4 did go into them multiplied. It did go into 12. That's false. So even though it's true sometimes, it's not always true. It's false sometimes, so it's overall a false statement. That's always tricky. So number 9. John took all his money from his savings account. He spent $72 on a radio, 2/3 of what was left on presents for his friends, put 5/12 into a checking account, and donated the $140 that was left to charity. How much money did John originally have in his savings account? That's a hard question. Let's try it by guessing. I'm going to start. Maybe he had $1,000. I have no idea. And then what did he do? Spent 72. So if you use your calculator, so you would subtract 1,000 minus 72. That would leave him with 928. And then he 2/3 of what was left on presents. So 2/3 on presents. So what is 2/3 of 928? That means 2/3 times, right? Of means times. 2/3, right? So it's 2/3 of what was left. So 2/3 on presents, 2/3 times what was left. 2/3 times 928. So if you take calculator, 2 divided by 3 times 928, I'm getting like 618 and then some decimals. I don't care about those decimals. I know this answer isn't right, but I'm just going to go on. So that's 618. That's what he spent, right? He spent 2/3 on presents. So what is he left with? 928 minus 618, which equals, I don't know what. 928. I'm just using my calculator. I'm getting 310 left. And then what did he do next? He put 5/12 in a checking. He put 5/12 away. So I'm going to take 5/12 of, right? 5/12 of his remaining money. 5/12 times the 310. So take your calculator, 5 divided by 12 times 310. I'm getting about $129. There's some change, but who cares? And what is left over from that? 310 minus 129, whatever that is. I'm getting 181. And what's supposed to be left? 140. Supposed to be 140. So that came out, what? Too high or too low? This is too high. 181 is too high. It's supposed to be 140. So I need to go lower than 1,000. So maybe John only started with $900. Let's try it again now. Spent 72. So 900 minus 72. That would leave him with 828. 2/3 on presents. 2/3 times 828. I'm getting 552. What would that leave him left? That would be 828 minus 552. I'm getting 276 left. And then he 5/12 away. 5/12 times 276. I'm getting 115. He put 115 away. So then what's left? 276 minus 115. I'm getting 161. That's still too high, isn't it? 161. It's supposed to be 140. It's still coming out too high. Let's lower it back down. Let's try maybe, we got closer, didn't we? So look, what did I do? I went down by 100. From 1,000 down to 900. And this went down by 20. So it's probably, let me go down to 800. I don't know. I'm sort of guessing. Spent 72. So that would be down to 728. 2/3 on presents. 2/3 times 728. I'm getting 485. About with some change. And then what's left? 485 minus this, or 728. It's the 728 he had here minus the 420. 728 minus the 485. That's equal to 243 left, and then he did 5/12 times 243. I'm getting 101 and some change. What's left? 243 minus 101. I'm getting 142. That's close, but that's still too high, barely. So now we're really close. We can try again. I'm going to come down just a little bit. 792. Try that. And spent 72. That leaves him with 720. 2/3 on presents. 2/3 times 720. That's 480. And what does that leave him? 720 minus 480. Just a lot of calculator work here. 240. That leaves 240. And then 5/12 of 240. That's $100. What does that leave him left? 240 minus 100, 140. Bingo, there it is. He must have started with 792. Originally, he had $792. So that's by guess and test table. Okay, so here's number 10. It says 5/6 of the students at a nearby college live in the dormitories. If 6,000 live in the dorms, how many students are there at the college? So let's say 5/6 of the college live in the dorms. So 5/6 of is always times. College, let's call that C. So we're trying to figure out how many people at the college. Equals, how many live in the dorms? 6,000. See, that's what it's saying. 5/6 of the college equals the number who live in the dorms, 6,000. So I want to take that equation and I want to solve for C. It's like a algebra equation, and C is saying, I want to be alone. Get rid of this 5/6 so that I can be alone. How do we get rid of that 5/6? You multiply by the upside down. Whatever you do to one side, you have no choice but to do the same thing to the other. The 6's will cancel, the 5's will cancel. The C is alone. Use your calculator. 6,000 times 6 divided by 5. 7,200 must live in the dorms. There we go.